friends. Today we will learn about direct reduction of a blast furnace. Direct reduction is the chemical reduction of iron oxides by carbon at high temperatures, approximately 1000 to 1500 degrees Celsius, producing metallic iron and carbon monoxide. Typical reactions FeO plus C is equals to Fe plus CO. This reaction is endothermic, meaning it absorbs heat. Where direct reduction occurs in the blast furnace. Direct reduction mainly takes place in the lower part of the furnace, where temperatures are sufficiently high. Lower Bosch. Tuere zone. Raceway. Cohesive zone. Lower boundary. At these zones, iron oxides are already partially reduced to FeO. Molten or semi-molten FeO comes into direct contact with coke. Stepwise role in overall iron reduction. Iron oxides are reduced in stages. In direct reduction, upper furnace. Fe2O3 reduced into Fe3O4 reduced into FeO occurs mainly by CO or H2. Direct reduction, lower furnace. FeO plus C reduced into Fe plus CO. Thus, direct reduction completes the final reduction step from FeO to Fe by C, carbon. Thermodynamics of direct reduction. Highly endothermic. Requires high thermal reserve zone, TRZ temperature. Consumes solid coke, increasing coke rate. Produces CO gas, which then participates in indirect reduction higher up. Because it absorbs heat, excessive direct reduction lowers furnace thermal efficiency. Increases fuel consumption.
Importance of direct reduction. Despite being energy intensive, direct reduction is unavoidable and essential because gas reduction cannot fully reduce FeO at very high temperatures. Molten FeO must be reduced before iron melting. It ensures complete metallization before hot metal formation. Typical contribution. In direct reduction, 60 to 75%. Direct reduction, 25 to 40%. Depends on furnace efficiency. Factors affecting direct reduction. First, coke reactivity, CRI. Higher CRI is equals to faster FeO and carbon reaction. Excessively high CRI is equals to coke degradation, permeability loss. Second, furnace temperature profile. Higher Bosch and Raceway temperatures promote direct reduction. Third, burden quality. High FeO content in sinter is equals to more direct reduction. Poor reducibility, high RDI, increases FeO reaching lower zones. Fourth, gas utilization efficiency. Poor CO utilization equals to more FeO descends equals to increased direct reduction. Fifth, alkalized slag chemistry. High FeO in slag increases FeOC reaction demand. Basicity affects FeO activity in slag. Relationship with coke rate. Direct reduction directly increases coke consumption. 1 kg FeO reduced directly requires 0.21 kg carbon. More direct reduction equals to higher coke rate. Therefore, modern blast furnace operation aims to maximize indirect reduction and minimize direct reduction, while maintaining furnace stability. Operational indicators of high direct reduction. High coke rate. High raceway temperature demand. High FeO content in lower zone burden. Low top gas CO utilization. Increased thermal fluctuations. Advantages versus disadvantages. Advantages. Essential for final reduction. Generates CO for upper furnace reduction. Disadvantages. High energy consumption. Higher coke rate. Increased thermal load on hearth and Bosch.